Shear force and bending moment diagram for statically determinate beam. Beam series part 3. Please watch the previous videos by clicking the links in description portion. It is a beam indicates loads and reactions. Loads and reactions are called as external forces. There are internal forces also developed inside the beam and maintain the equilibrium. Internal forces. Several internal forces shown in the diagram. Understanding purpose, above forces indicates in different places. If cut the beam as two pieces, then able to analyze the internal forces easily. Now cut the beam imaginary as two pieces, one LHS piece, left hand side piece, and other right hand side piece. Now analyze the internal forces on LHS and RHS surfaces. LHS and RHS internal forces are opposite direction to each other. If combined two portions, both are eliminate each other. This is called as shear force. This shear force acting parallel to the surface. Normally positive shear force to LHS part consider as downside, and positive shear force to RHS part consider as upward direction shown in the slide. This is the bending moment. Bending moment. Bending moment acting perpendicular to the cutting surface. Most of the US books consider anti-clockwise moment positive for LHS and clockwise moment positive for RHS portion, or otherwise commonly say for LHS and RHS, that is sagging moment positive. This term discussed later. Axial force. This is axial force. Axial force acting perpendicular to the surface shown in figure. Here consider tension is positive. That is, this force pull the surface, pull this surface, pull this surface. This force pull this surface. Other internal force, important internal force, torsion. Torsion acting moment parallel to the surface, that is a twisting moment shown in figure. In previous slides, we discussed 4 types of internal forces. One shear force, second bending moment, Third, axial force, that is compression or tension. Fourth, torsion. In beam calculation, generally bending moment and shear force are predominant. In truss calculation, axial force analysis is predominant. In rotating shaft calculation, torsion analysis is predominant. See this figure. This is a beam, therefore we consider only bending moment and shear force. This is a LHS portion, this is RHS portion. Let us consider this above sign convention are positive, that is LHS shear force downside positive, RHS shear force upwards positive, LHS bending moment anti-clockwise positive, RHS bending moment clockwise positive or sagging positive. This is a simply supported beam. The point X lies 3 meters from left support. What is the shear force and bending moment at point X? Firstly, find out the support reactions. That is already found. 7 kilonewton and 17 kilonewton. Firstly, cut the beam at X and analyze the equilibrium. Find the shear force and bending moment. Be able to consider LHS or RHS. This is our sign convention, positive sign convention. This is a LHS part, this is a RHS part. This is a point X, here point X, here also point X. This is a positive sign convention for LHS. Positive sign convention for RHS, this one. Consider the equilibrium condition of LHS or RHS and find the shear force and bending moment. Consider LHS portion. This is a LHS portion. Write down the equilibrium equation. Equilibrium equation number 1, summation of net upward forces equal to 0. This is 7 upward positive. Consider upward is positive. Here downside minus 6. V is downside V is equal to 0. V is equal to 1 kilonewton. Shear force at X is equal to 1 kilonewton. Next equilibrium equation. Take moment about X. Take moment about X is equal to 0. Take moment 7 into 3. 7 into 3. We consider clockwise moment is positive. Here we consider clockwise moment is positive. 7 into 3 is 7. This moment about X, 7 into 3 meter clockwise, therefore 7 into 3 positive. Minus 6 into 1. This is 6, this one 1. This is actually anti-clockwise moment, therefore minus. And this moment is actually anti-clockwise, therefore minus m is equal to 0. Therefore M is equal to 15 kilonewton meter. Therefore bending moment 15 kilonewton meter, shear force 1 kilonewton at X. Let us try for RHS side. Should be same answer. Actually no need, but understanding purpose only. This is the RHS portion. This is the RHS positive sign convention. Consider upward force is equal to 0. V upward minus 18 plus 17 is equal to 0. Therefore shear force is equal to 1 kilonewton at X. Take moment about X. X, consider clockwise is positive. Consider. Therefore 18 into 2 is a clockwise direction. 17 into 3 is anti-clockwise, therefore minus, and this external this moment is actually clockwise, therefore positive is equal to 0. Therefore M is equal to 15 kilonewton meter. Same answer, should be same answer. Question: draw the shear force diagram of above beam. Now we have to draw the shear force diagram of the beam. Firstly, find the critical points of the beam. Find out the critical points of the beam. Normally, this is a beam. Okay, this is a beam. These are the critical point. Critical point number 1. Just after support, just before 6 kilonewton, just after 6 kilonewton, just before 18 kilonewton, just after 18 kilonewton, then just before support. These are the critical points of the beam for this example. Then secondly, cut that points and consider LHS or RHS. Find the shear force and bending moment. This is end. Shear force and bending moment. So okay, next step, cut this point, consider LHS or RHS, put the positive sign convention and find out the bending moment and shear force. Again cut this, cut here and analyze this point, cut that point and find out the shear force and bending moment. Same time, similarly, cut here, analyze that point, find out the shear force and bending moment. Unfortunately, take time, analyze this point and find out the values and draw the shear force diagram. But unfortunately, take time. We will see the shortcut method in next slides. Therefore, move to shortcut techniques and save time to draw shear force diagram and bending moment diagram. Shear force diagram shortcut techniques, actually techniques, not method, techniques. Move from left to right, all upward forces are adding and downward forces are subtracting. Move from left to right, all upward forces are adding and downward forces are subtracting. Or move from right to left, move from right to left, all downward forces are adding and upward forces are subtracting. For this sign convention, these are the shear force diagram technique. Now let us draw the shear force diagram using shortcut techniques. Consider left to right movement. Upward forces positive, downward forces negative. This is a 7 kilonewton upward force, therefore plus 7. Start from just after support, plus 7, plus 7, plus 7. There are no loads, plus 7, plus 7, plus 7, plus 7. This is a 6 kilonewton downward force, minus 6, 7 minus 6, 1, 1, 1, 1. There are no dots, 1, 1, 1. Again, this 18 kilonewton downwards, therefore minus 18, 1 minus 18 is equal to minus 17, minus 17, minus 17. Finish just before the right hand support. Start just after left hand support. Okay, this is the shear force diagram. This is a 7777, 7 kilonewton. This is 111, 1 kilonewton. Minus 17, minus 17, minus 17. This is a minus 17 kilonewton shear force. This is the critical point. These are the critical points. Here 7, just before the 6 kilonewton 7, just after 6 kilonewton 1. Here just before the 18 kilonewton 1 kilonewton, just after 18 kilonewton minus 17 kilonewton. This is a shear force diagram. This is a simply supported beam with UDL. Omega is equal to 2 kilonewton per meter. Span of the beam is 6 meter. Point X 2 meter away from left hand side supported. Point Y 3 meter away from left hand support. Actually Y is the midpoint. What are the shear force value at X and Y? Question is, what are the shear force value at X and Y? Okay, firstly find out the support reaction. That is essential. Support reaction, this is 6 kilonewton. Other one 6 kilonewton. Check the previous video, support reaction calculation videos. Answer. Let us do the calculation by shortcut techniques. That is, move from left to right. All upward forces are adding and downward forces are subtracting. In the case of UDL, we consider area of the UDL diagram is a force. If UDL, area of the upward UDL diagram adding and vice versa, that is downward UDL diagram, area of the downward UDL diagram subtracting. Let us find the shear force at X. This is the beam. Actually, this portion of the beam no need, because we consider left to right movement up to X. This left to right 6 kilonewton plus, because upward force. this area minus this area minus, because downward side, 2 into 2 minus, therefore 2 kilonewton. Shear force at x is equal to 2 kilonewton. Now consider y point and consider left to right shortcut techniques. This is the y point. Shear force at y is equal to, this is a left to right movement up to y. 6 is a plus 6. 2 into 3 minus, because downward area. 6 minus 6 is equal to 0. Okay, check the right to left technique also. Check one time. Or now consider right to left movement. This is a y point. Now consider right to left portion. This portion of the beam, no need actually. Shear force at y is equal to minus 6, because upward force, right to left, upward force minus 6. This is 2 into 3 plus, because downward plus is equal to 0. Both answers should be same. Now draw the shear force diagram of the beam. Now consider shear force diagram. Firstly, identify the critical points. These are the critical points just after support, this one just before support, and this is a symmetric case, therefore we consider midpoint also critical point for easiest work. Okay, consider left to right movement. Shear force techniques, shortcut techniques, shear force shortcut techniques. Here this is a 6 kilonewton, upward, therefore plus 6. This distance is negligible, just after the distance is negligible, therefore influence of UDL, there's a nothing. No UDL influence here. This is UDL. Therefore 6 kilonewton upward, 6 kilonewton. Next critical point is this one, midpoint. This 6 here, 6 minus this area. 6 minus this area, 2 into 3. Because it's downward force, we consider left to right techniques, therefore downward force minus. Therefore 6 minus 6 is 0. Shear force at center of the beam is equal to 0. Here, this case. Next, this is another critical point just before the support. This 0 here, 0 minus this area. Y minus is downward force. 2 into 3, again 2 into 0 minus this area. This is a minus 6. This 6 kilonewton shear force. Here shear force 0. Here shear force minus 6. Therefore this is a shear force diagram. This is a 6 kilonewton. Here 0. Here minus 6. This should be straight line. This one should be straight line. Why? Okay, discuss later. This one should be straight line. This is a simply supported overhanging beam. Actually statically determinate overhanging beam. This is the overhanging portion. These are the support. Firstly find out the support reaction. 7.5, 32.5. Now we have to draw the shear force diagram. Okay, firstly find out the critical points. Identify the critical points. These are the critical points of the beam. Just after left hand support, this one, just before 20 kilonewton, after 20 kilonewton, before 32.5 kilonewton, after 32.5 kilonewton, just before the 10 kilonewton. Okay, now analyze the shear force at these critical points. Shear force of this point actually 7.5, because 7.5 kilonewton. We consider left to right movement, left to right techniques, therefore upward positive. Here 7.5 upward, therefore 7.5. This point, shear force at this point 7.5 minus this area, because downward 1 into 10, 7.5 minus 10 minus 2.5. There's no force, therefore here minus 2.5. There's no force up to this point, minus 2.5. Minus 2.5. Minus 2.5. Here minus 2.5. Again minus 20, because downward. This point, shear force at this point minus 22.5. Again this one minus 22.5. There are no loads, therefore here also minus 22.5. Here minus 22.5 plus 32.5, because upward force, plus 10 minus 22.5 plus 32.5 plus 10. Here plus 10 shear force value. Here plus 10, here plus 10 plus 10, up to here plus 10. Now draw the shear force diagram of the beam. These are the shear force values get from previous slides. Okay, this is a shear force diagram. Here shear force value 7.5. Here shear force value minus 2.5. Here also minus 2.5. Here minus 22.5 kilonewton. Here minus 22.5 kilonewton. Here plus 10. Here plus 10. Plus 10 plus 10. These are the shear force values. In point load case, the point load is a concentrated load, therefore shear force diagram should be jumped. Here another point load, support reaction point load. This shear force diagram jumped. Okay, this 7.5, this one minus 2.5, connected by straight line, should be straight line, connected by straight line. Here minus 2.5 is the same, there are no load, minus 2.5. Here again jumped because of this concentrated load, jumped. Same value, again jump because of this point load, jump. Again there are no loads, therefore same value up to just before this point load. Unfortunately, this length unknown. This is 10 meter. Okay, this one 10 meter, but this length is unknown. We can find this x value by triangular techniques. Consider these two triangles. This two triangle 7.5, this one x, this one 10 meter, therefore this one 10 minus x, this one 10 minus x, this one 2 point, don't put minus 2.5, this is the consider triangular side, therefore don't put minus 2.5, 2.5. This is the opposite angle, this one theta, opposite angle same. Tan theta for this triangle, tan theta is 7.5 over x. For this triangle, tan theta is equal to 2.5 over 10 minus x. Both are same, and find the x. X is equal to 7.5 meter. This is a 7.5 meter, this one 2.5 meter. This is the shear force diagram. This is a cantilever beam. Draw the shear force diagram. Firstly, find out the support reaction. 10 kilonewton. Moment 80 kilonewton meter. Check the previous video. These are the shear force values. Consider left to right technique. Therefore upward force positive. Here 10 plus 10. There are no load. Therefore 10 10 10 up to here. This is a shear force diagram. Plus 10.